recording.
Alright, so
We got it started. Alright, there we go.
alright,
Yeah.
thanks Adam. Okay, wow, what a great turnout. We're just like 2 weeks
I
notice.
think you need the mic.
Yeah, we need those lights.
This mic over here.
Well, I'll get ready for you.
Right. Thank you.
Hello. Alright. Okay, can you guys hear me okay in the back? Alright, yeah, thanks everyone for showing up. We're just like a 2 or 3 weeks notice. It's a pretty good turnout for our first meetup, so it's just great to see such a big demand for it. I'm Reza, I'm from Beanworks, and this is Matt from Fishworks.
Why is there no food here?
Next meetup.
Beans and fish.
So, yeah, so we're not from Docker, we just really love Docker and just figured out we should start the meetup and promote it, and in the meanwhile, we all learn more about it, so that's the whole reason we started this meetup. And it's great to see such a good turnout. So, basically we're gonna have 2 presentations. We're gonna have an introduction presentation about Docker and what it's all about, and then Mark from Hootsuite is going to give a talk about how they use Docker currently at Hootsuite. So we're going to give a little background on why Docker can be useful and what we should do with it, what we could do with it, and how it can help us with the DevOps. And Matt's going to, sorry. Matt's going to go into details on more about like the whole LXC containers and namespaces and how what Docker is built upon. Alright, so I'm sure if you guys have been to the Docker website, you've seen this slide. This is basically shows the evolution of IT. So how the applications used to be back in the days in the 1990s, you would have just one big server, you would install everything in your database and your application, everything on it. And basically, you would have to replicate the same thing on your QA environment, your production environment, your stage environment, everything like that. But nowadays, people, with the great rise of open source, people download a lot of like applications from, get a lot of libraries, download them from wherever they can find and put them together and get the application up and running. But unfortunately, which is all great, but unfortunately, not a lot of these applications that people get work nicely with each other. So you run into problems when you put them together. They might use the same port or use the same file. All sort of conflicts can happen. So, and every time you want to deploy this application, you would run into problems on how you should basically configuring it and setting it up for different. If you want to like set up your server from scratch, you're going to run into problem of basically you have to do this thing all over again. So that's the problem that we're facing right now. So a good analogy that we could use is basically shipping. So back in the days, everyone, like let's say you had a car or basically a car box or a piano and you wanted to ship it, you would have to like stack them up on top of each other in a ship and move them from country to country. Basically put them on a ship or put them on a train, put them on a plane, store them somewhere. You run into all these problems of how to nicely put them together. What if they interact with each other or could damage each other? So basically, what the industry came up with is the concept of containers, which is put them all in the container. You can rack them up nicely together. You can put them on a ship, put them on a boat, put them on a train, store them, put them on a truck, put them anywhere. So basically, improved how people actually move goods around the world. So why don't we just apply the same concept to software? So yeah, so we have all these components. You have a website, you have a database, you have all the background workers, all the API servers, UI servers that are running, and you want to run them on EC2, you want to run them on your local VirtualBox, you want to run it on your VMware, you want to run it on all these different environments, and they're not going to play nicely if you just manually go from scratch and installing it. You're not guaranteed that the application that you're running on your QA server is going to be exactly on your stage is going to be in production, so you run into all these problems. So that's when Docker comes into play. So what Docker does is you containerize all these applications that are out there and put them into these containers, and you can nicely deploy to your dev environment, your QA environment, your stage environment, and you're guaranteed that it's going to be behaving exactly the same way as it was in your stage as in your production. So it saves a lot of time with DevOps on basically setting up new servers or ensuring that the application runs properly. So yeah, so why should I care? For developers, you basically build it once and you're guaranteed that it runs everywhere, right? So, and you don't have to worry about what environment it's on. As long as it's on a Linux that supports LXC, you're guaranteed that it basically it's going to work. And for DevOps, you just configure it and run it anywhere.
You might want to explain what LXC is.
What's that?
You might want to explain what LXC is.
Yeah, we'll get into it. So I'm going to pass over to Matt, and he's going to go into more detail about what LXC is all about.
Hey guys, so a little bit of a background on Docker. So it was introduced last March at PyCon 2013. Sullivan Heights presented it to basically the world. They took out DocCloud, one of their biggest projects is open source PaaS. Well, not open source, sorry, it was a public PaaS. And they containerized and they took one of their projects and they basically broke it up and they made it public and they called it Docker. They saw a huge community behind it, and so right now, as we're counting, it's about 10,000 stars right now. Massive community behind it, a lot of people, Red Hat, just huge amount of community. It's Apache v2 license, so it's completely open source. You're free to work with it, you're free to do whatever you want with it. And then, as Reza said previously, it just packs, ships, runs processes. That's all it does. It's a simple way to have a known state of a file system and to run a process upon that. Whether it's CentOS, whether it's Red Hat Enterprise, whether it's Ubuntu, any of those that just have a Linux kernel above 2.6, although 3.8 is recommended because of just some LXC namespace issues. And then as well, you can save the file system state in images, so you can build upon different images as you go along. So you can build like a base container, and then say you want your database on that base container, you can build upon that. If you want to have some extension of that, you can build upon it. So it gives you the extensibility where you can build upon different Docker images. So it's a huge win for that. And then along with that, like building upon images, it's just a huge win for automation. You can use something that's known as a Docker file. Then you can explain what process you want to run in certain ways, and it will save each image as you go on, and it will go into what it used to be was AUFS, which was a copy on write. But nowadays they've made a new device mapper that allows you to basically, you don't need dependency on AUFS, but you are capable of doing that. So that's how it goes. So what Docker is based around, it's a large wrapper around LXC, which was introduced in, I think, 3.8 or 2.6 was when namespaces were introduced to the mainline kernel. But LXC is basically similar to CH root jails. So if some of you are familiar with CH root jails, what it does is it allows you to basically run a process or anything like that in just a small jailed place. So if you rm-rf root, it won't actually crash your entire system and it won't break. You won't remove your entire file system, your devices, and everything else. So it gives you a way to run a process level virtualization. This is not the same as a VM though. This is running on one virtual machine. You can run multiple containers on the same machine. It's all really powerful like that. And then it relies on C groups, which is for resource limitation, like you can limit your CPU, you can limit your memory, your disk I/O, and this is all in the mainline kernel. So a good example to show this, like for comparing, because a lot of people ask, what is the difference between a container and what's the difference between a VM? So you can see in the picture that when we're having a VM, we have a host server on the very bottom level, which is say like your VMware ESX server. And then you have an operating system, whether that's Windows, you have it on, or your host OS, which is just whatever you want it to be. And then your hypervisor on top of that is going to be VirtualBox, or it's going to be VMware, it's going to be ESX, any of those kinds. And then you can run on top of that a whole bunch of different virtual machines. So you can have Windows on there, you can have Ubuntu, you can have all that. And it has its binaries and libraries, and then it has whatever app you want to run on it. So you basically run a virtual machine, you install all your applications and everything on there, and then you throw your app on there and it's a virtual machine in there. So the simulation with, or the similarity between containers in that same sense, is that you have your server, and you have your host operating system, so you have Linux or Ubuntu, or Red Hat Enterprise, or anything like that, the Docker supports, Arch Linux even. And then you have your engine, which is just a small daemon that runs on the server, Docker D, that basically is the wholehearted wrapper around LXC containers. And then when you're doing that, you have binaries and libraries, and those are held inside each of these inside a container. These are all small containers that it's trying to visualize, and you can share binaries and libraries between them as of 0.6. Docker allows you to link containers to them. That's what you're asking. So I mentioned about saving file state and Docker images. So what that basically is just a file system state that stays on as a tarball or anything like that. So it's just a read-only layer for your file system. And it's just, when you have an image, you build upon an image, and then you build upon another, and it's just like a diff of the previous image. And you just keep on building and building and building, and you just get this large stack that you eventually get, and that's your container. And it's just a whole bunch of small tarball bits, really. Yeah, sure. Go ahead, no. And then something else that came along that is somehow you need to be able to save your images in some way. So you can save it on your host VM or on your host operating system, and you can save it and it's just a small tarball and it's an image. But what if you want to share it amongst users? So the Docker guys came out, well, Docker Inc. now, they came out with what's known as the Docker registry. They originally had a public registry and it was completely closed source. And they had a whole bunch of guys coming up to them and say, hey, can I please have your Docker registry, and can I put this on my own hardware? And I said no. So instead, eventually, they came up and open sourced their private registry. So there's a public registry, it's index.docker.io. And you can go on there and you can search up images that people have uploaded. You can search, there's trusted builds. You can see what their Docker files are for how they built them, all their different stacks, and a whole bunch of cool different stuff. They're actually going into putting on private repositories as well, so you can have like kind of like the GitHub workflow where you can have public repositories and private repositories, so it's public images and private images. So the Docker registry for the public or the private version, which is the one that's open source, is built entirely in Python. And then all it does really is it just stores images as a JSON file, and it just uploads them to the server on whatever backend you want, whether that's OpenStack Swift, or that's Amazon S3, or OpenStack, any of them. So basically what you get is when you go into the Docker registry, it's simply just an API that allows you to see what different things. So this is just a simple curl call of just going onto the API and searching for a repository that I just pushed. And it has this image, and it's just stored as a very long ID. And so that's the ID. This is its Docker image parent, so that's the image that it's built upon. And the time in which it created, so it was created on March 14th at 2:59. Has no command, no volumes bound onto it. And then it has a whole bunch of different things like environment variables and all that. And it just saves all that inside the Docker registry. It's a fun little project. So to explain it at a higher level of how this works for how sharing containers between people can work with a Docker registry. So you have a base container image, so say like BusyBox, or Ubuntu, or Red Hat. So you have your base container image. And then inside that, or on top of that image, you would run a process. That process may or may not adjust the file system. It may just run echo hello world for all you want. You really can get less. And it just runs a command. If you change the file system state, there will be a modulus of the base container, so it'll just have a small tarball diff. And then you can commit that or container into a image. And once you do that, you can share that and throw that and push it onto a Docker image registry. So what that does is that base container image, and then the diff of that base container image is pushed onto the registry. So you can now share it amongst other people, and people can pull that base image and that container and say, hey, I want to run whatever you have on there. So say like I had Postgres database on there. Yeah, just push it and it'll be the exact same environment as it did on my VM as it will be on yours or on my laptop or over on my production server. It'll be the exact same. And then if you want to update images, you would just pull it and you would just make another image on top of it. Just make a new diff and then commit it. It would make another image on top of that, and you can push it back again. You can just run it on the same host. So yeah, it's just host running A, pushing, pulling from another one, and it just runs it. Yeah.
Just wondering if you could talk about host volume mounts.
Oh, host volume mounts?
Well, you talked about Postgres, so I was just asking about the half the people in the audience who may not have worked about before. Where do you put your DB files, things that should live inside your image?
Yeah, so there's a concept known as volume bind mounts, which is basically that what you can do is you can bind a file or a specific folder that's on your, or an inode that's on your host operating system. And you can actually bind that into the actual VM or into the container. And you can basically, so say if you have persistent data on the Postgres database, or if say you have like an uploads folder on your website or something like that that's running in a container, if you have that, it'll just, it's basically like a shared, almost like a shared folder between a VM and a host. It's practically the same thing. So you can do that for sharing data between like a Postgres database or anything like that. So I just wanted to take a minute to thank our sponsors for this. So Aquaman, they're the company who I'm contracted to. They've given us the free beers. You can thank them for that. Docker Inc. is the one who actually started up this meetup. Reza contacted me originally and said that he was really interested in starting up this meetup. And I was like, yeah, let's do this. And Docker caught wind of it, and they just started up the meetup and off with that. And we have to say thank you to Hootsuite for giving us this awesome venue. This has been really good. Yeah, there's some stickers as well if you guys want them as well. Yeah, that's what we got. So, any questions about just higher overview of Docker or anything like that? Bueller?
So Docker only natively works on Linux right now, right?
At the moment, yes, but there are plans actually right now to put it on Windows. They're actually looking at that 090, they actually took it out and made it their own independent device mapper or device mapper adapter. So they're trying to look on putting it on Windows.
Cool. And then, have you ever used it for Java or anything like that, or?
Yeah, I actually, I have an actual project, or private, not private, a public repository that I have, a whole bunch of small little Docker files. I've installed Elasticsearch on there, which relies on Java 6 or Java 7. I think it's compatible with Java 8 now as well.
Java 8 was just released today, so.
Oh, okay. But yeah.
That's what it is. Yeah, you can test it.
No, that works fine. It's been around for a while, I know.
Yeah, but so you can install Java onto your actual container, and then you can start throwing your application on there. Yeah, it's possible.
By Java, you mean JVM?
Yeah, your JVM, correct.
Yeah, I do that and it works fine. Some limitations of what you can stick inside. I don't know if it's on this, but about a month ago, OneStart, this is needed to work well inside.
Yeah, there are some funny little things about Pitline.
Yeah.
So I guess your image registry is usually self-hosted, right?
Yes, usually I wrote up a blog post about a month ago on how to host your own private repository or registry, like SSL and putting on like different things so you can make it so that people have to authenticate in order to push applications, or if you're a developer, or you can pull applications without any authentication.
Are there any decent services offering that? Like GitHub, Docker?
There are a couple of services out there, not that are coming off the top of my head, but I know there are a couple of public SaaSes out there that are doing public registry that are allowed. And then there's also the Docker public registry who's doing it very,
So are you
yeah.
talking about like a hosted private registry?
Probably.
Pardon?
Probably.
What is it?
Oh yeah, there's a couple of others as well, like DocStack. Yeah.
There were a couple issues with sometimes your firewall does your various layers of the
Yeah.
They don't download completely.
Yeah.
they've got CDN issues or something screwing it up.
Yeah, I've been working with Optiman as well. Yeah, there's been some CDN slow issues that we've been finding around with Trusted Builds as well.
Yeah.
So there are a couple of things they're still working out those kinks, but yeah, we're working on
So
it.
I'll just put it out that if you're distrustful of the registry repository side of it, you can always just do straight cargo shipping with Docker import, Docker export.
Yeah, that's always a good option as well.
Yeah.
All right.
Yeah, there's a service called Koi.io that is basically it's like a private repository that you can pay $25 a month for up to 25 repositories. They're pretty good. The developers they're rapidly releasing new features on it. So I was on there at like 10 p.m. and I was talking to the tech support. They were online helping me.
Thanks.
Yeah. Any other questions? Okay, just a show of hands, I meant to ask in the beginning, how many people are basically consider themselves advanced Docker users here?
You should be sitting
Phil, you should be standing.
How many people have used it? Alright, cool. How many people are just here for the beer?
I also created a story in my year on it. That's the value of it.
Yeah, anybody use it in production?
Yeah, I don't think we've got anyone, because we build products on top of Docker.
Yeah.
I think it was, but I don't think anyone's in production with the version we have in Docker. We've been using LXC containers for like 3 years.
Yeah, same.
And we just replaced it with Docker. But yeah, I don't really know. I don't think so.
Who would charge it enough to go in production now?
Well, it's still not in full production
Yeah.
1.0 yet.
Yeah, who
It's
decides
at
that?
4.091.
This might be a dumb question, but like, how hard or how long does it take to like every application have you put it into your Docker container? Is it like just run a script, or is it like it'll take 10
So you have
minutes?
this concept of Docker files that you basically put a bunch of commands, and it basically runs through it and executes those commands and creates a Docker image. But then you can cache, it uses caching mechanism. So if your base images haven't changed, it just reuses them. So depending on how many commands you're running, it's not maybe like a minute or two, or depending on how many commands you're running. But booting it up it's not really booting it up, like opening the container is like instant.
It's like running a process. Like this is a Docker file, this is an example. And it just shows that this one is just an Apache 2. Oh, sorry. This is just an Apache 2 Docker file that just really all it runs is just, it runs apt-get update, runs apt-get install. So this is one image that it saves. And then this is apt-get install Apache 2. That's another image. Expose is port 80, that's an empty image, it just updates the metadata inside the container. And then this is just the entry point inside Apache, so it just runs Apache in the foreground. And that literally takes as fast as it would as you just go apt-get update, apt-get install on a regular host VM. It's just running and isolated inside the container. So you can do this a million times and you'll get the exact same process every single time that you run it. And actually, because it's an image, you can actually cache it when you're doing Docker code. So you can actually make it so that it'll apt-get install Apache 2. And if you modify something later on, it'll just cache these 2 images and just use them later. So arguably, sometimes it could be even faster than just doing it yourself.
Yeah. And you can also, if you're scared of that turning into a massive long shell script,
You just make it into one giant image.
well, aside from just doing step by step what you do,
Yeah.
call it to your Puppet, your Salt, whatever inside of there,
Yeah.
and then it'll cache it in the same way that you've got your config management.
Yeah, if you inject your PEM files and all that,
Yeah.
just run that bootstrap in there, off you go.
Is Docker in the app repositories and stuff? Can you just do an apt-get install Docker?
Well, yes and
server?
no. If you look on docs.docker.io, they actually have their own mirror where they host.
Oh.
And you can actually go and add that repository in, add the GPG key, and apt-get install LXC Docker on Ubuntu. On Arch Linux and other ones, there's like something on the AUR or the Arch user repositories. Yeah, a whole bunch of different options. It's all there. Yeah.
I have a question about the verified images. Like, I was browsing through, I saw like 5 very similar verified images on like this sort of movie. Like, how does this verification go? So do they go in and try to remove duplicates?
So trusted builds is what you're talking about? Yeah, so basically
Can
it's
you repeat the question?
so the question is how do trusted builds work in a better sense? So trusted builds is something that Docker had recently come out with, and what it does is it allows you to verify that this Docker image was built with this Docker file. Previously, what it used to be, you could just build an image, rename it something, and then just push it to the registry, and everyone would just trust you that it works that way. But usually people found that to be undistrustful, so what they did is that they would just say, like, just go to my Docker file and just build it. But Docker actually was pretty smart about that. They built trusted builds, so you could actually specify your Docker file is at this repository at this certain sub-level, and just build it with this. And so it'll just actually show you the Docker file. It'll build it through that, and yeah, trusted builds come out pretty easy. So like installing Ruby or something like that, you just, say you have like an application, and it's like a Sinatra app, and it just has a Docker file in there, just to bundle it all up and put it in a Linux container. You would just have a Docker file in your root repository or anything else. Then you would go on to the Docker index and just say, I want to create this as a trusted build, and here's my repository, and here is where the Docker file is located in the repository, and it'll pull that and it'll start building the build for you, so people can go in and just say, oh, it's verified. So, it's a cool way to trust them.
In other ways, do they go in to try to remove duplicates? Because some of them are very similar.
So trying to remove, or like say someone pull or pushes like Sinatra Hello World, and another person does Sinatra Hello World, it's kind of the same thing as GitHub. If you have two of the exact same thing, you're going to have two of the exact same thing. Whether on the back end, I'm not knowledgeable of how they do it on the back end, they may cache something. I personally don't think they do. I think they may only cache your trusted builds images. But yeah, always free to talk on Docker Dev or on their IRC. So yeah. You good?
Yeah.
Any other questions? Okay. All right.